Hello and welcome to Global Math Mentor. This is lesson 3 on complex number from the Pure Mathematics 3 syllabus of A Level 9709. And today I'll discuss another essential skill in this course, which is find the two square roots of a complex number. So they have given an important instruction. For example, the square roots of 5 plus 12 iota in exact Cartesian form. The emphasis is on exact and the Cartesian. Remember from my previous video that this 5 plus 12i is a complex number in Cartesian form. So stay tuned for more videos and I'll show you how to get the polar and the exponential forms of complex numbers. Another idea which is very important and worth noting, full details of the working should be shown. The reason they're asking to do this is because some of the modern calculators have the capacity to give you the answer straight away, but such working won't be credited. So you need to show details of your working, okay? So I wish to find the square root of this complex number. Remember the square roots from your normal real number system. For example, I'll take an example of a perfect square. Let's say 9. The square roots of 9 are plus and a minus 3. Similarly, I know that the square roots of this 5 plus 12 iota, let me just erase this one, yeah, will be two complex numbers of this form, a plus iota b. So let's dive into it and see the Cartesian method of finding the square roots. So I'm taking the same question from the syllabus document 5 plus 12i, and I'll show you the work, what you need to do in order to find the square roots and the full details of my working. So grab on your notebooks and let's begin. All right? Okay, so if this is a situation, I'm looking for the square roots. First thing I can do is square both sides. When you square both sides, what happens? You get rid of this plus and a minus because a positive square is a positive, a negative square is a positive as well. Okay? So a plus ib square, this is what you get. Now you need to expand this double bracket. I know some students do not learn the identities, the algebraic identities, just like I am using. It's really good to apply mental mathematics. A squared plus 2 aib plus iota b whole square, right? So you can write it like this. Or you can simply, if you are not familiar with this, you can just expand this double bracket, right? And this can help you get your answer. So the answer should be a squared. This iota squared b squared will become a minus b squared and plus 2abi. There is a reason I wrote it like this. Have you noticed I shifted the negative b squared with a squared and the 2abi on one side? Reason, the method that we use in such situation is equating real and imaginary parts. Okay, let me write this for you. Equating real and imaginary parts. You might be wondering that what does it mean equating real and imaginary parts? So look at this. We've got a 5 on the left-hand side and a squared b minus b squared. How do we know this is the real part? Because it doesn't have the coefficient of I, right? And this 12 over here is the imaginary part on the left-hand side, and 2ab is the imaginary part on the right-hand side, okay? So when you equate real and imaginary part, you will get a squared minus b squared equals to 5, and 2ab equals to 12, okay? Now I need to solve this system. This is a linear and a quadratic system. Let's begin. So I can simplify this equation to become 6 over a from this equation. All right. I made b the subject. Substitute it back in the quadratic equation. So I get a squared minus, in place of b, I'm going to substitute the value 6 over a squared equals to 5. A squared minus 36 over a squared equals to 5. Okay, now this looks a bit tricky, but let's solve this. using algebra. I'm multiplying the whole side with a squared to get rid of this denominator of a squared. This becomes a4 minus 36 equals to 5a squared. Okay. Okay. So let me just do the working over here. This standard equation becomes a quartic equation. What's a quartic equation? Quartic. It's a fourth degree equation, right? But we haven't learned about solving quartic equations. Yes, we have, but if the factor is given and so on. So such equation can be dealt with from the pure mathematics 1 syllabus, equations can be modeled as quadratic. So I will suppose let u be a square. Okay. This will help me. This implies that u square will be a to the power of 4. So my fourth degree equation can be modeled as a quadratic equation. So this will look like u squared minus 5u and minus 36 equals to 0. If you have lost the track, you can just rewind the video and go back and catch up. Don't miss out on this working. So it's somewhere around 5 to 6 marks on your pure mathematics 3 exam. You need some serious work to pull this one off, right? Okay, so u squared. Now I am using the middle term break. You can go with the quadratic formula, but remember, show your work just the way I am doing. So normally these questions can be done without the calculator, right? Okay, so u minus 9 plus 4 and u minus 9 equals to 0. So u plus 4 and u minus 9 equals to 0. U becomes a negative 4 and u becomes a positive 9. Are we looking for u or are we looking for a squared? We're looking for a squared, right? So a squared is a negative 4 or a squared is a positive 9. Now keep in mind, what did I tell you about the definition of the complex number? Remember, if z is a plus ib, a is the real part, B is the imaginary part, but A, B itself, originally, they are real numbers. So this is not applicable. You need to reject this part of the solution because this will give me the value of, what will be the value I get for A? A will become plus minus 2 iota, right? So you can check this if either in your calculator in the complex mode, or you can simply square root it and check that square root of 4 is a 2, but the square root of a negative 1 is a I, right? So this is the valid situation, plus minus a 3. Now I need to get my B values as well. So B 6 over A, since B is a 6 divide A, okay? So you can say when A equals to a positive 3, B equals to 6 divide 3, that's a 2. And when A equals to a negative 3, B is a 6 divide negative 3, which is a negative 2. So one of the square root is 3 plus 2i, and the other is a minus 3 minus 2i. You can give these answers in a combined way by writing plus and a minus 3 plus 2i. All right? So this is how you can find the square roots of a complex number, and using algebra and without calculator. I already told you there are some fancy tricks in other exam boards, like in the IB application exam. You can use your GDC to get the square roots of a complex number. And sometimes, even in the pure mathematics, you can use the De Moivre's law to get the square root, because De Moivre's law, I'll discuss in my later videos, is a technique by which you can find any power of a complex number. So you can raise a half power to get the square roots, but you will be needing a calculator, and sometime the question might ask you, without using a calculator, find the square roots of a complex number. Okay, next I'll solve another example, and I'll give you some time to go over that question first, so you can pause the video and check my work later, right? All right, this is a question. Find the square roots of the complex number 3 plus 4 iota, showing all steps clearly. Pause the video and give it a go. Then you can come back and check my work. Okay, let's go. So I wish to find the square roots of this complex number. And I know that they will be of the form a plus ib plus and a minus, right? Just like the real number systems, there are two such numbers with a plus and a minus sign. So now you can square both sides. Okay? This will become 3 plus 4i. And now, since I did the full explanation on the previous, I can clearly write it like a squared minus b squared plus 2abi. So you can rewind and check how I did it earlier. It's just expanding the double bracket, right? Okay, now equating, I'm not writing it, but you can write in your exam, equating real and imaginary parts. So a squared minus b squared becomes 3, and 2ab is a 4, right? So b becomes 2 divide a. You can either make a the subject, it doesn't matter. Sub it in the quadratic equation. This becomes a squared minus 4 over a squared equals to 3. Now you can time the whole equation with a squared to make a fourth degree equation, which, just like in the earlier question, I solved it using substitution. So I'm taking it up there, the step. A4 minus 3a squared and minus 4 equals to 0. You can suppose anything. Let's say y equals to a squared. You can suppose any arbitrary alphabet for this. So this becomes a quadratic equation now. Y squared minus 3y minus 4 equals to 0. Okay? So let's factorize it. I mean, it's not necessary it's factorizable all the time, but normally in the questions where they don't want you to use the calculator, they give you questions which can be dealt without the calculator, right? So 4 times 1 and 4, I'm just factorizing the quadratic, and y minus 4 and plus 1, a y minus a 4 equals to 0. So finally, I get a y4 and a y minus 1. So what happens from here? This is just a supposed variable. I was actually looking for a squared. A squared is 4, or now, sorry, I'm just working everywhere. So you see I moved it there. You can just rewind and don't miss out on anything. Just stay focused. A squared equals to minus 1. This is not applicable. Reason that this will give an imaginary value for a. You can write, since a is a real number, right? That's why I cannot use this value, because if it's a real number, the square of a real number is never negative. So a can be found from this side. A squared equals 4 gives me plus minus 2. Now quickly use this equation to get the value of when a is 2, b is a 1, and when a is a minus 2, b is a minus 1, right? So these are my two answers. 2 plus I, because it's a plus iota b. So it's 2 plus I, or minus 2 minus I. How can you give the answer in a combined way, right? You can write plus and a minus, 2 plus I. And there you have it. This is how you can find square roots of a complex number. And stay tuned for more useful, valuable lessons on the same topic. Over and out.